So for the worksheet number 12, we'll go through the whole thing. We'll go step by step. Where did my other pen go? Does anyone see my other pens laying around here? I'm going to have to use just one of them. All right, so first thing we do is graph it. So I'm going to have you put a good graph down. We'll wrap these up on our calculator today. For now, we're just going to graphs. We're going to graph y equals x cubed. You should know that one, a nice parent function. So go send that on through like this. I missed the origin, so I'm going to make a big dot there. We're supposed to find the area that's bound by that function, y equals x cubed, and this is what makes this one unique compared to yesterday. I didn't give you the other function, but I told you it's a tangent line through this point over here at 1, 1. So right here, there's a tangent line that's going to nick the curve. It's going to head over here, and it's going to also intersect the curve over there. So I need you to go shade in that area bound by both of them. So let's go shade that in. Grab my pencil. Let's go get a highlighter and shade this in. This is the area we're in search of. We're just going to use yesterday's stuff to find that. All right. So first thing I need to do is we pretend we're coloring. And we're coloring with these little vertical rectangles. Remember, I'm making an infinite amount of them. They're so thin I can't even see it. But when I'm all done 20,000 billion years from now and still not quite done, I'll have the area of the entire yellow region. And each one of those little things that I'm coloring with is a rectangle. And its base is dx, and its height is the distance between the functions. And to get the distance between the functions, yesterday we said you subtract them. So I'm going to integrate from here to here. The problem is I need to go figure out what this intersection point is. And in order for me to do that, I need to figure out the equation for the red line. So way back in chapter 2, we said an equation for a tangent line requires a point. I've got one. It also requires a slope. And the slope is its derivative at that point. So we're going to go to my blue curve. We're going to take its derivative. We'll call that y prime. And it's 3x squared. At 1, 1, the derivative would be what? 3. Yeah. So at 1, 1, that's going to have a slope of 3. It's just the derivative at that point. So to write my equation for the tangent line, I do y minus the y I know is equal to the slope there times x minus the x I know. Raise your hand if you were able to tackle that hurdle in your homework. And you should have been. We've done equations of tangent lines a lot. We just didn't do it yesterday. So I'm going to solve this for y. I'll get 3x minus 3 plus 1. So that red line is the line 3x minus 2. So this is what I have here. I've got the bases being dx, the bases of all my rectangles. I have the height being the distance between the curves. And yesterday we said you always do top function minus bottom function. The top function's the cubic, which is x cubed. The bottom function's the line, which is 3x minus 1. This whole expression right here gives me the height of every single rectangle. So then the only thing I need to do is get my limits. I can see I'm going to be doing it till I get to 1 because it said through 1, 1. The problem is the intersection down on the left. This one was calculator active, wasn't it, on your worksheet? So I allowed you to go calc intersect on your calculator, entering this in y1, entering this in y2, or if you could just troubleshoot it and see. I can kind of see it because I'm guessing it's at about -2 because I can kind of see it. And a -2 cubed gives me a -8, and a -2 in this line gives. So I am 100% confident without calc intersect, but if you need it, then you would math 9 that. Who got it right with the math 9? Can you give me the answer? Because I don't have my key here. About
6.750.
750. All right. So that was number 12. I'm also going to address number 11 with you. So those of you who did it on your worksheet, check it. If you didn't or you were absent, which is there are a lot of you, you can just, you should have the worksheet unless you were gone due to illness. Then write it on a separate sheet. We're also going to address number 11. All right? So for number 11, you have y equals 2 sine x as one of your curves. You could graph it by hand. It's just a vertical stretch of the sine wave, but this is calculator active, so we're going to make use of the fact that we get to use a calculator. There's the two functions that are going to intersect. On the interval from 0 to pi, I'm going to find the area enclosed by those two curves. So calculator active means let's go grab our calculator and enter it in. I have it up here from last hour, so I'll just erase my work and re-put it on later. So when it's calculator active, make it graph it, but make sure you watch your window. So when I hit my y equals, I've got both of those functions in there. I don't know why I have that one. But there's my 2. I'm going to have the sine wave in blue, and I'm going to have the cosine wave in red. Before I hit graph, I'm going to take and address the window. If you look at number 11, what does it say that x go from? 0 to pi. So when I go into my window, you need to go from 0 to second pi, and I went by pi fourths because it's tricky. I like to go by either pi halves or pi fourths. It really doesn't matter which, or even if you went by ones, it doesn't matter, but I like to have that be pi. I kind of OCD with my graphs. All right, I also made a calculated decision with my y's because what's the range of the sine function? -1 to 1. What's the range of cosine function? -1 to 1, but one of those is double. Was it the cosine one that was doubled, right? So I chose -2 to 2 just so I had a beautiful window. That's not super important either, but the x ranges, the x min to x max is important so you don't leave the interval or be in the wrong interval. Once I hit graph with that, I got this really nice function. That was the sine one, that was the cosine one. I was to find the area trapped between the two curves. If you got it wrong, I bet you missed these two little pieces at the ends. And you probably did because you didn't mess with your window, so you didn't see them. Because if it's on a really small window, you're going to miss these. So I need to set up a couple integrals. How many? I could do 3. Or I could outsmart it and do how many? I could do 2. If I go from here to here, and again, I'm just coloring, and I'm coloring with rectangles, an infinite amount of them, but that's from 0 to the intersection right here. Can someone share that intersection so we don't have to calc intersect it? 0.375. All right. I'm going to do top function minus bottom. If I do it backwards, by the way, you'll know because you're going to get negative, and we're working with area and volume this chapter. So you shouldn't get any negative answers. Make sure you do the red one. That was the cosine. I'm going to do top function minus the bottom function. What was it sine? Just plain old sine x? 2 sine x, thank you. All right, so top function minus bottom function. I'm going to get this lobe for free just by doubling it. If you didn't and did it separately, you would have the right answer. Did anyone think to do that, to double that little piece there? It's kind of a way to trick it. Then from here to here, I'm going to be integrating from 0.375, and then I had to go calc intersect that on my calculator. Can someone share that one with me? 2.768 is what I'm hearing. 7. All right, good enough. And now my top function's different. The top one on this one is that sine wave, the sine 2x, or 2 sine x, I'm sorry, minus cosine 2x. From here, because it's calculator active, I shouldn't see you doing any antiderivatives. I shouldn't see any u sub. I should see you going immediately to your calculator and using which command? Math? 9. Exactly. So I don't know what the final answer is to that. You'll have to look on your sheet. So you can go ahead and make sure your name's on the top of that. Send it up. If you were absent, I'd like that tomorrow. We're going to go take a good chunk of notes right now. So pass that up. Meanwhile, open your notes. We're going to go right here. So open your notes to this page. All right. So it's says sometimes it's easier to make horizontal slices. I'll show you what I mean by slices. I told you yesterday I was pretending I was coloring it. I was coloring it, though not haphazardly. I was being very deliberate with how I was coloring it. I was doing vertical rectangles, going from the left to the right, and then my integration added them all up, and I just headed up and went that way. But Dalton could certainly decide that he's going to deliberately color from the bottom to the top with horizontal rectangles. And won't I get the same area regardless of my methodology for coloring, right? Usually the vertical way is quicker, it's safer, and it's easier, but I said usually. So I'm going to do an easy one both ways. Then I'll go do one where horizontal actually is better, and then we'll discuss how you know which method to use. So first thing, same as yesterday, the first thing you need is a super great graph. So it doesn't have to be detailed, it needs to be big, and it needs to be accurate, but it doesn't have to have tick marks and all that kind of stuff. So I'm going to throw out the square root of x, which we know because that's our parent function. I'll go nice and slow today, especially with all the absences. We'll see if we can. Boom. So there's my square root function. I'm supposed to do y equals 0 as well. So that's my x-axis. I'll do that in red. Make sure you watch the rest of the notes, guys. And then x equals 4, we'll do in blue. And I'm going to go pull a 4 on here. Go shade that region in. I'll give you guys enough time to make it. We're going to do this the way we did it yesterday, which is how I would choose to do this one. And then we're going to tweak it and approach it horizontally. Raise your hand when you're ready to start the calc. All right, we're good. So from yesterday, we said you're going to start going like this. They're so small you can hardly see them, so I said blow one of them up. I said color it in. It's called a representative rectangle, and notice that its base right here is a little change in the x-axis. This is what we would call later in the chapter a dx problem. It's got vertical slabs. I am going to add up a whole bunch of them from left to right along the x-axis. I'll travel from 0 to 4. And the base of every rectangle is that dx. Its height is the distance between the functions. How did I say to do that? Top minus bottom all the time. The top function is x comma root x. It's root x high. The top, or its height, would be root x. The bottom function in this scenario is actually just 0. Go math 9 that really quickly and somebody spit out the answer. If we can confirm it, we'll move on. Go math 9. From 0 to 4, root x dx, and we'll approximate it to our minimum of 3 decimal places. 5.3 repeated. Perfect. That's how I would always do this problem. But there's a certain reason why this one works out best that way. And so we're going to go do it coloring a little differently. We're going to get the exact same answer. So we're going to wash, rinse, and repeat here. I'm going to go make the exact same function. I'm going to shade that in again. You guys slow me up if I'm going too fast. I'm still going to take this and find the area of the yellow stuff. Here's how I'm going to approach it differently. I'm going to color this way. Still making rectangles. They still have area. They're still infinitely many. They're still super thin, and I'm still never going to finish. But if I approach infinity, I will get the area of the whole thing. I'm going to blow one of those up so I can see it a little better. I would never make them this thick, but I'm going to blow it up. Here's how the problem changes. This right here, its height is no longer dx. Guess what I'm going to call it? Yeah, it's a little change along the y-axis, and we call it dy. And because I'm going to be coloring up the y-axis, I'm going to be going from 0 to how high this is. Now, I'm not going to go right from 0 to 4 on the x. I'm going to go up. And this is the point 4 comma what? 2. Yeah, because the function's the square root of x. So I'm going to change how I do this. I'm going to have everything now in terms of y. I'm going to color from 0 on the y-axis up to 2, and I'm going to color horizontally. The rectangle still has 2 dimensions. It's just this time one of them's dy. So this is calculus of a single variable. I need this all in terms of y. I've got my limits from y, 0 on the y-axis up to 2 on the y-axis. I've got the height of my rectangle in terms of y. The problem that I now have is this right here is no longer top function minus bottom function. Guess what it is? Right minus left. Exactly. And it's an x-coordinate. So how far over is it to the right minus how far over. If this was 4 over and this was 1 over, that would be 3. Right? So I need to actually get the change in the x length, but it needs to be in terms of y. So here's the deal. This is locked in. No matter where I did the rectangle, that would be 4 to the right. So the 4 is fine. The right function will be 4 no matter what. The left function, though, you might say, well, it's on the curve, so it's the square root of x. That's its height. So you have to go up here and solve this for x in terms of y. What would x be? Y squared. Exactly. So although you might say every point on this curve is x root x, I could say, no, it's not. It's y. Y squared. Does it jive with this point? Does it? It's 2 ways. It's just one has x as the independent variable, which is what you're used to from Algebra 1, and y equals f of x. This is the reverse of that. Y is going in, and y squared comes out. So your right hand is 4, and your left side is y squared. Go run that through your calculator. Go math 9 it. You'll get the exact same answer we got coloring vertically. We should. All we're doing is coloring. We're just changing whether you want to swipe up and down or swipe left and right. You'll still get 5 point. What do we get? 3 repeated? Yes. Notice it's the exact same area of the exact same figure. Which way do you like better?
First
one. Oh, of course. Right? And if you had your choice, just 1 second, you would do the first one. You only do the second one in 2 situations. When it says use horizontal rectangles, or when vertical, you get to an impasse, and we'll throw one of those up. What's the question?
It's really the same thing, but negative.
Then what you did is backwards.
Oh,
You
yeah.
did y squared minus 4. And I know that he should be raising his hand and saying, I got a negative. Because what does this, your answer represent? Area. You should have a positive answer for the rest of this chapter. So next up, we're going to go do a similar one. And you can cross that off. We didn't do example 5 yesterday, so we're going to do this one both ways, vertical and horizontal. First thing, in your homework, don't worry that the notes are long. You have 4 problems to do for me tonight. You'll get 2 of them probably done before you go. The other 2 will be homework. The catch is it's a problem set, so you're going to have to be very detail-oriented, but only 4 problems tonight. So I'm going to go graph it. My first function is square root x again. So let's shout that out nice and big. Don't make them tiny. Y equals 0 again. It's the x-axis. So I know my shaded region for sure has to be above the x-axis because it's bound by these 2 functions. And then they're also giving me this line. I know that's got a y-intercept of -2. It goes up 1 over 1, up 1 over 1. You can see it's got that x-intercept at 2, 0. I'm going to go draw it. And then you need to shade in the region in question. That region in question, I think I'm going to use this to do my highlighting. I wonder if that will work. Color, highlighter, there. Now I don't have to keep switching. I'm going to do it purple. All right. Oh, I should have thought of that this morning. I've been switching that pen out all day. Now I can use my finger every time I want to highlight. That I'm going to get the area of the purple stuff. So suppose, right? Suppose Rachel's like, I hate the dy stuff. I'm always going to color vertically. She'll almost always get the right answer. But this is what happens on this one when you color vertically. Let's just pretend. She's going to go like this. She's going to start at 0, right? And she's going to do these vertical rectangles. And the top function, square root x. What's the bottom function? I'm just going to keep going. What's the bottom function? 0. Okay? And she's good for a while. But then right here, when she gets here and starts to color, now she's got an issue. Because now who's the bottom function? Yes. So she has to know that and use 2 integrals. So she's going to color it actually in 2 pieces, and it's legal and you'll get the right answer. So let's write vertical. If you decide to do this one vertically because it was your choice and that's what you chose, you're going to go from 0. Are you all right, honey? Okay. You're going to go from 0 to here, which is obviously 2. Okay? From 0 to 2, the top function, again, I'll draw my nice representative rectangle in there so you can see it. I'll do it in green. But here's what I'm using. And everything's going to be about x. This is a dx problem. And from 0 to 2, the height of this is root x. Top function minus bottom function, which is just 0. That will give her all of this. Green. Then she's going to have to reboot and go plus 2 to, do you know what this point is right here? Are you pretty certain, or do you think you have to go calc intersect? It's 4. Just by observation, it's 4. Or you could set the functions equal and solve, but I wouldn't. That one's easy just by guess and check. That's going to go in 4. Now your integrand needs to change. Because in here, top function is still root x. Minus, what's the bottom? It's looking very Christmassy. What's the bottom function? What's the bottom function now? X minus 2. And it has to go in parentheses. Now, take out your calculators. Go math 9 that thing and get some of these commands out of the way. I'm going to wait. I'm going to have you go math 9 it. And if, I think I was using Rachel as my example, if that's what she decided to do, and it didn't say how to do it, have at it. You'll get the right answer. Run it through your calculator, and you guys give it to me to 3. Is this the one that's 3.3 repeated? Here's one of them today, that is. I'll let you guys. By the way, I know your calculator doesn't care what variable you use in these, so even when we do dy, just go ahead and use x on your calculator. It is 3.3 repeated, right? That's what Eva got. Okay, so 3.3 repeated. Had I worked it out by hand, I would have got 10/3. But we're not going to go do by hand today. We did that yesterday. All right, but if it says you have to use horizontal rectangles, or maybe on this one you might think they're easier. When I do it horizontally, I'm going to go erase some of this. Oh boy, I have to put it on there a little better. But when I go do it horizontally, here's my function. All right, I'm going to reshade. Use my fingertip. All right, so back to the exact same picture. Here's what makes the horizontal ones nice in this scenario. When you're doing horizontal, the same functions on the right the whole time, and it's same functions on the left the whole time. You can do it in one integral. All right, right minus left, there's never a function change. So I'm going to integrate, but I'm now, if I make one representative rectangle on here, you guys are listening so well, I've now got what I'd call a dy problem. So everything has to be in terms of y. I'm going to climb up the y-axis from 0 up to what? 0 up to 4. And I can do it in one chunk of coloring. I never need to disrupt it. I've always got blue on the right, right? Actually, that's 4, 2, right? What am I coloring up to? 2. Is that why your hand was up? Yep, thank you. You triggered it in my brain. I'm coloring up from 0 up to 2. Now I'm going to do right function minus left function. Well, you have to be careful. You can't say, oh, x minus 2 minus root x. Those are how high they are. Those are x's, and we're working with y. So you just need to go up here and briefly say, well, your x coordinate is really y squared. That's really what that is. And on this one, your x is really what? Y plus 2. That's how you're going to write it. So when I go do right minus left, the right is the linear function. I'm going to say y plus 2 The left is the quadratic function, and we're going to say y squared. What if you reverse them? What's going to happen on your calculator? What are you going to get? You're going to get negative, and you'll know that. If you go math 9 that, you're going to get the exact same thing as this one. So I'm going to repeat. Which one are you going to choose 9 out of 10 times? Vertical or horizontal? Vertical. The only time you're going to choose horizontal is if they tell you to. If it actually says use horizontal rectangles, or if you're doing vertical and you're like, man, I got to make 3 of them. And then you look at it horizontally and you go, wait, Eric on the right doesn't change. We're going to do one more, and then that'll be it for today. Whoa. Yep, actually I have 2 more. 1.5. So here I want you to point at this. You're always used to the function saying y equals. When it says x equals, that's kind of a dead ringer. For horizontal might be, I'm writing eyeballs. When you see that, it means you're probably going to color horizontally. We're going to go graph it. This is calculator active, so have your calculators out. X cubed isn't necessary on a calculator. You can just go slap it on there. Here's the deal. You have what's called a function grapher on your desk. It only graphs functions unless you put it into one of its other 3 modes, which you won't do until Calc 2. But if you were to press the mode button on your calculator, when you buy it, it's defaulted to function mode, and it'll stay there until you get to Calc 2 and you start moving it over. In Calc 2, we move it over to the other modes, and we start graphing things that ding around. They're like screensavers. We make flowers, and we make hearts, and we can make, you can make a circle in one command. When you're in function mode, you can only enter functions in there. So here's how you need to tackle that. Until you get to a higher level of math, you're going to have to solve it for y if you want to get it on your calculator. You're going to have to be super careful that you realize that this is plus or minus. Yes?
Calculator can do x equals.
No. No. Not if you're in function mode.
Oh, okay.
It won't. It'll only graph a function, and you're going to see when we piece this together, this is not a function, this one right here. So this will go in y1. In y2, you're going to have the positive root, and in y3, you're going to have to enter the negative. You're going to have to outsmart your calculator into graphing a non-function by splitting it into pieces. So when you go to your calculator and enter all 3 of them, the positive square root x plus 2 is going to look like that, which is a function. The negative 1 is going to look like that, which is a function. Combined, they are not. What in algebra 2, why did they tell you that's not a function? Yes, it's failing the vertical line test, but we outsmarted it. And we got our region up there. You're going to go color it in. So go color in the shaded region again. And we're going to talk about if you have your choice, what might be your choice for this one. Otherwise, you have to be super careful. So I'm going to use Sophie as my example this time. Rachel, I'll give you a break, okay? Sophie decides that she too is a horizontal rectangle bigot. And so she's going to do vertical because she just got it out for the horizontal ones. And so she goes over here and she starts to color. Right here, the top function is positive root x plus 2, but the bottom function is what? Negative. And she could still do that. She's just going to have to go root x plus 2 minus negative root x plus 2. She can only do that until she gets to here, at which point she's going to have to reboot, right? And split up her integral. Are you with me, Sophie? Because I'm pretending this is you. And you're not doing it horizontally no matter what I tell you to do, unless you know you're going to lose points for it because you have to get everything right. Then if I force her to, she's going to go horizontally. But until then, she's having at it this way. She's going to have to stop right here. She's going to have to calc intersect this to figure out where am I stopping, right? But she'll go from negative 2 to there, top minus bottom. But then the top remains the positive root x plus 2. But what does the bottom become over here? What's the bottom function? X cubed. And it'll work. But this is one where it would be to your benefit just to color horizontally. Here's why. When I look at this sideways and I start coloring like this, who's always to the right? The cubic. Who's always on the left? The inverted quadratic, right? So I don't need to switch functions. It's blue on the right, red on the left. So I'm going to set it up that way. I'm going to integrate from, and I'm going to be going up the y-axis. So when you go calc intersect, unlike yesterday where you were looking for the x-coordinates, let's do the left side of the room, go calc intersect down here. If the right side of the room can go calc intersect up here, and all I need is the y-coordinate. Actually, this one I can do by guess and check. I think that's a -1. Is that right? -1 will give me a -1. Yes. I know that's right, but the top one I think you need, it's going to be decimal. So actually just the right side of the room. If you could go calc intersect that top and point, or 1 point, 2 point, what is it? I'll wait for you guys. Takes a while. Do you have it for me, Chris? Top y boundary?
It was, the y was 1.793.
Can someone back that?
Yeah.
Oh, thank you. 1.793. So I'm deciding that I'm going to color up this way. My rectangles actually have a dy base. So I'm going to go dy. I'm going to go up the y-axis. Now I've got to do right minus left in terms of y. So let's go look at the right function. It's this one. What is it in terms of y? What is x? Cubed y. Exactly. So you're going to rewrite that. And they're not hard to solve. X equals cubed root y. That's how far to the right you would be. So you're going to go cubed root y. Right function. Minus the left function. It's already written as x in terms of y. Right? It's y squared minus 2. Tell me what's going to cause my answer to be off. Just to make sure you're paying attention. It looks like you are, but what's wrong with mine? Yeah, thank you. It needs parentheses. Go math 9 this and you'll have the right answer. Now again, like I said, had Sophie decided to go from left to right and done her 2 integrals and not made any sign errors, she will have the right answer. So I'm going to repeat. When do we color vertically and do dx? Most of the time. Okay? The only time you're going to go horizontally is if it says to. Otherwise you're going to get a mark wrong. Or if doing it vertically, you have to break it up too much. So last one up for the day. Here we go. This is going to be calculator active. So I'm going to write CA for calculator active. We're going to go graph it. I'm going to graph it as quickly as I can. I don't need a calculator to graph this one because it's easy. E to the x is exponential growth. E to the 0 is 1. I'm going to hit at 0, 2. And again, I leave everything unticked. I don't really care. I just need its general shape. Trevor, pick on you next because you look a little sleepy, kiddo. It's hard when I'm talking into the headphones because I don't interact with you guys as much. You get very sleepy. What does the y equals 2 minus x squared look like?
Oh,
What's its graph look like?
it opens down.
Yeah, it's a parabola. It opens down and it hits at 0, 2. So notice I made a fairly big graph because my area in question is that tiny little sliver right there. That's all I had to do for part A was sketch it and indicate the region. That's good enough. Part B just says find the coordinates of points of intersection. Well, one of them's obvious and requires no work. What's one of the intersection points? Like 0, 2. Alright, so that one's free. The other one, I need you guys to go calc intersect it. So again, I'm going to take a minute. We're all calculator active today. Yesterday we did some by hand, but not today. I need you guys to go give me the x and y coordinates of that intersection point to 3 decimal places. And Rachel, here we round to a minimum of 3 for p. You can go more, but no less. So we'll calc intersect that thing and I'll steal an answer. It's going to be negative something.
Negative 0.715
Okay, negative 0.715. I'll take it.
and 1.489.
1.489. Thank you very much. All right. So there's my points of intersection. Done. Now for letter C, does letter C say to do vertical slicing or horizontal? Okay, I'm going to do it up here, just so you do it down in letter C, but it says to do vertical. And that's how I would do this one. If it were me, I would be just fine with vertical. And again, here's why. When I start to color, the red's on the top the whole time, the green's on the bottom the whole time. I need one integral. These are already solved for y. Why would you go do it the other way? Right, Rose? It makes way too much work. Vertically, I can just integrate, but remember I'm going left to right. So I grab the x's. It's all about the x. So I'm going to go from negative 0.715 to where? 0. Rachel, was this in your Calc 1 at college? Usually this is the first section actually in a Calc 2 course. It's just, usually, like a lot of you seniors who take this next year, you take Calc 2, you'll start with this stuff. College Board tests on the first 2 sections. That's why we're just doing 7.1 and 7.2, and the rest of 7 you're going to get in college. Have you done this, like discs, washers, and that stuff? You were just going to start it for second semester? Yeah. It's usually Calc 2 or in college, but we're just doing the tip of it. Anyway, top function. Who's the top function in this scenario? Be careful. So if you do it backwards, you'll know because you're going to get negatives. But who's the top function? 2 minus x squared. And I want everything in terms of x because remember, this little representative rectangle is helpful. This is differentials on the x-axis. So I do dx. I do top function. I do minus bottom function. And I make sure I lock and load it in parentheses. I math 9 it. We'll wait for Chris to go math 9 it really quickly while we move on, just so I'm not wasting your time on the calculator. He's going to get us a number for that. Meanwhile, we're going to go, you got it, what is it?
0.082.
And then a 4, right?
Yeah.
Yeah, I'm going to go to 4 decimal places just because I don't like one of them being 0. OCD. All right. So for part D, it says to do the exact same one, but it says to go horizontally. I wouldn't choose this one to do this way, and here's why. When I go horizontally, what happens is I do have this same function on the right the whole time, and I have the same function on the left the whole time, so it only needs one integral. Whoopsie daisy. But why do you think I wouldn't choose to do it? What am I going to have to do in the process of this? I'm going to have to change the functions to be saying x equals, which isn't hard. We'll go do it. But let's go through it, start right here. I'm now going to integrate up the y-axis. So I need everything in terms of y. I'm going to go grab my y bounds. So I'm going to be going from 1.489 all the way on up to 2. So 1.489, oh dang it, my pen's broken, all the way up to 2. Just going to go put that over there. Now I need the right function, but everything's about y. So you're going to go to the right one. Which one's on the right? The e to the x one or the quadratic? E to the x. You need to solve it for x, because it's to the right. It's an x coordinate. So you're going to say it's y minus 1 equals e to the x. Oh no! It's just beeped in my ear, and it means that it's almost done recording. That's okay. Stop beeping. All right, anyway. How do I undo the L, all right. How do you undo e to the x? ln, yeah, you're going to ln y minus 1. So the right function is going to be the natural log of y minus 1 minus. The left function, you're going to have to go solve this for x. So what you're going to do is say x squared. There's a lot of notes today, I apologize. Tomorrow, though, there's almost none. You're going to be in groups working. So x squared equals, this is beeping in my ear. It's like, all right. So what's x? Plus or minus. But in this scenario, is x plus or is it minus? What are they? What are your x's over here on this curve? Are they positive or are they negative? Negative. So when I solve this and it is plus or minus, I need to kind of use my own decision-making skills to know that that's going to be minus the negative one. So which method is easier? And if Chris goes launches that through his calculator and puts x's in place of all the y's, because your calculator doesn't care. You can call it ln p minus 1 plus root p minus 2 as long as you go dp, and your calculator will do it for you. You're going to get the exact same answer, am I right? Yes. So, in this scenario, last thing I'm going to say, which one's better? Vertical or horizontal? Which one's almost always better? What one are you going to try first in your entire problem set? Okay, we're done. Your problem set is, boom. Yeah, man, that went. My fingertips activated. Bet you never heard somebody say that before. I need to unactivate. There we go. Come on. Alright, just a second. I have to go manually click it, and then I'll get you your stuff. I have lots of... I can't see.